Planck black holes. This is the smallest black hole size that the laws of physics permit to exist, so small that a single proton would look enormous sitting next to it. Its predicted temperature is unthinkable, tens of quadrillions of degrees hotter than the core of the Sun, making it, in theory, the hottest thing the universe is physically capable of producing. But its real claim to fame is how briefly it would exist. Compare it to a mayfly, an insect that lives for roughly a single day and is often used as the textbook example of a short life. Next to a Planck black hole, that mayfly might as well have lived since the age of the dinosaurs. It exists and disappears faster than the idea of time even has a chance to apply to it. It vanishes almost instantly. What comes next might still be out there right now, quietly surviving since the birth of everything. Primordial black holes. In the first fraction of a second after the Big Bang, before a single star or galaxy had formed, the newborn universe was an unimaginably dense soup of energy. In certain pockets, that density was high enough for space itself to collapse inward, forming what we call primordial black holes. Some of the smallest predicted examples would be barely 0.5 millimeter across, roughly the size of a grain of sand, yet would carry the mass of an entire mountain range, an object as heavy as Everest, shrunk down small enough to slip beneath a fingernail without you ever noticing. Unlike the Planck black hole that blinked out of existence almost immediately, a primordial black hole formed in those first moments could theoretically still be drifting through space today, invisible and untouched, older than every star in the sky. Kugelblitz black holes. A Kugelblitz is a black hole made from nothing but concentrated light energy. No dying star, no collapsing matter, just an extraordinary amount of light packed into a small enough space that gravity takes over anyway. Einstein's own equations allow for this. Mass and energy are interchangeable in general relativity, and the universe genuinely does not care whether that energy started out as matter or as pure radiation. This raised an uncomfortable question when a powerful particle accelerator went online in 2008. A handful of physicists worried that the extreme energies involved might accidentally create something similar on a microscopic scale, a real micro black hole. Micro black holes. The physicists running that accelerator weren't worried, and their reasoning was solid. Any micro black hole created in a lab like that would be smaller than a single proton and would evaporate almost instantly through a process called Hawking radiation. More importantly, cosmic rays slam into Earth's atmosphere every single day, carrying far more energy than any lab-built collider can produce. If micro black holes could form from these collisions and start consuming matter around them, nature would have already created and unleashed them countless times over the planet's history. You wouldn't be watching this right now because the Earth itself might not still be here. The micro black hole, it turns out, is essentially harmless. The next entry on this list is not, and if one appeared close enough to our solar system, you would never get the chance to finish this sentence. Stellar black holes. A star dozens of times more massive than our Sun burns through its fuel over millions of years, and when that fuel finally runs dry, its core collapses in less than a second, faster than a human nervous system can even register pain. The outer layers of the star are blasted outward in a supernova, while what remains behind is a stellar black hole, the mass of dozens of suns compressed into something smaller than a city. Here's where it gets strange for you personally. If someone watched you fall toward a black hole's edge from a safe distance, they would never actually see you cross it. From their point of view, you would appear to slow down freeze at the boundary, and gradually fade into darkness forever. But from your own perspective, falling in, you would feel nothing unusual at all. You would simply keep falling, and then you would simply be inside, with no way back and no way to tell anyone what you'd found. Rogue black holes. Some black holes are violently ejected into deep space the instant they're born. If a supernova explosion pushes harder in one direction than the other, the newborn black hole can be flung across the galaxy at millions of kilometers per hour. No star, no light, no warning, just an invisible mass drifting silently through the darkness between stars. There could be millions of these rogue black holes wandering our galaxy right now, most of them completely undetectable, except for the rare moment they pass in front of a distant star and briefly warp its light. In 2022, astronomers confirmed the first unambiguous detection of one roughly 5,000 light-years from Earth, an object that may have been drifting unnoticed for millions of years before anyone realized it was there. Binary black hole. Mergers. Sometimes two black holes find each other and become locked in a slow gravitational spiral, orbiting closer and closer as they radiate away energy in the form of gravitational waves, ripples spreading outward through the fabric of space-time itself. In the final instance before collision, they can orbit each other hundreds of times per second at more than half the speed of light. When they finally merge, the collision releases more energy in a fraction of a second than every star in the observable universe combined. In 2015, the LIGO Observatory detected the first confirmed gravitational waves from exactly this kind of event, a merger that happened 1.3 billion light-years away. By the time that signal reached Earth, it had stretched our detector by less than the width of a single atom, and yet we still caught it. If you've stayed with us through the ones that could reshape a planet's fate, hit like and subscribe, because what's coming next turns an ordinary feeding black hole into something that could sterilize a world without a moment's warning. Supermassive black holes. At the center of nearly every large galaxy in the universe sits a supermassive black hole. Ours is called Sagittarius, a star containing roughly 4 million times the mass of the Sun. Yet from Earth, its event horizon would appear no larger than a tennis ball resting on the surface of the Moon. Every star you can see in the night sky, including our own Sun, is slowly orbiting it. Right now, our entire solar system is moving around Sagittarius A star at more than 200 kilometers per second, and one full orbit takes roughly 230 million years, meaning the last time we completed a lap, dinosaurs hadn't appeared on Earth yet. In 2022, astronomers finally captured a direct image of it, a glowing ring of superheated gas wrapped around a perfectly dark center where light itself simply disappears. For now, it sits quiet and dormant. But even the largest sleeping giants eventually wake up and feed again. Quasars feed a supermassive black hole enough surrounding material, and the galaxy around it starts to vanish behind the glare. The spiraling disk of infalling gas heats to such extreme temperatures that it can outshine every single star in its host galaxy combined. These are quasars, the brightest sustained objects known to exist in the observable universe. The most powerful known quasar consumes the equivalent of an entire sun's worth of material every single day, launching jets of energy from its poles that stretch across millions of light-years. Most quasars belonged to the younger, denser, more violent early universe, but some are almost certainly still burning out there today. Blazars. A blazar forms when one of a quasar's high-speed jets happens to point directly toward Earth. Most known blazars are safely distant, but if one ever formed within a few thousand light-years of us, the consequences would be immediate and catastrophic, stripping away our ozone layer and exposing the surface of the planet to lethal cosmic radiation. There would be no warning beforehand, since the jet itself travels at the speed of light. The first sign of its arrival would be the damage already underway, entire ecosystems collapsing beneath an invisible beam that had been crossing the galaxy for millions of years before it ever reached us. Ultramassive black holes. Some black holes grew so enormous that astronomers had to invent an entirely new category just to describe them. Ultramassive black holes exceed 10 billion times the mass of the Sun. The most famous, TON 618, is so large that if it replaced our Sun, its event horizon alone would swallow every planet in the solar system and extend billions of kilometers beyond Pluto.